Hello everyone. Today we will solve some of the problems in current electricity before we move to the next chapter. So the question given to us is this. This is the figure. A network of resistors which is placed along in the shape of a cube, right? And you see that along a body diagonal we have connected a cell and a resistor, right? So A and D, right? This is a body diagonal, right? This is not the phase diagonal. You know, obviously you know that there is a difference between the phase diagonal and the body diagonal. So along the corners of a body diagonal there is a cell connected, there is a resistor connected. We need to find what is the equivalent resistance between A and D. Basically means that along body diagonal what is the equivalent resistance, right? So before doing that, before starting this problem, it looks like this problem is very complex and all that, but if we start dealing with this, we will understand that how simple it can be, right? How simple it can be. For example, let's say you see, if let's say if current I is entering here, right? So current I will exit also from here. So you know that whatever current this cell is supplying, it will also get the same current. So current I is entering and current I is leaving from this whole network. So can I write simply that the equivalent resistance is nothing but E by I? Equivalent resistance is nothing but E by I, correct? Now we basically need to figure out how this I will distribute among all these resistors, right? How this I will distribute among all these resistors, right? Okay. So let's understand like this. For example, now you can see by the network that all these are symmetrical networks. So obviously it will be distributed equally along all three branches, which will be I by 3, I by 3 and I by 3, right? Because if you see, there are three networks from here. One, three branches basically, 1, 2 and 3, right? And every branch follows same path to go to the destination, right? But if you are not convinced on whether these three will be equal or not, let's assume for some time that they're not equal, right? Let's assume that this is I1, this is I2 and this is I3. Now we have assumed that the current entering in these three branches are I1, I2 and I3, right? Now again, let's follow this path. So this current I1 is traveling around IB. Again, it has two paths here. One is BCD, another is BED. But if you see, these two paths are exactly same, consisting of two resistors. So it will get distributed equally. You can guess that. So this becomes nothing but, this becomes I1 by 2 and this also becomes I1 by 2. Correct? Now similarly for I2 and I3 as well, this becomes what? This becomes I2 by 2 and this also becomes I2 by 2. For I3 if I see, this becomes I3 by 2 and this also becomes I3 by 2, right? Now let's collect all these and see what is the status at the outgoing, right? So here in CD, I2 by 2 is coming from here, I1 by 2 is coming from here. So CD is getting what? I1 plus I2 by 2, right? This is a simple KCL. Now again, here, this is getting I1 by 2, I3 by 2. So this ED will get I1 plus I3 by 2. And talking about this particular path, and I think I missed drawing a resistor here. So this particular path DG, it is getting I3 by 2 from here and I2 by 2 from here. So this basically becomes I2 plus I3 by 2. So if you add all these three currents, you get I1 plus I2 plus I3, which is basically I. So I is nothing but I1 plus I2 plus I3. And here also if you add all three, CD, ED and DG, you get I1 plus I2 plus I3, which is basically I. Now to solve all this complex circuit, we basically use what? We use Kirchoffs law, right? We use Kirchoffs voltage law. The current law is obviously we are using here, right? So for example, if I take any closed loop here, we have multiple closed loop, EFGD. If I take loop EFGD, right? So if I apply KVL here and put signs and everything, you can just do that by yourself. This becomes minus R I1 plus I3 by 2 and this becomes plus R I2 plus I3 by 2 and again this becomes plus R I3 by 2 and minus R uh, minus R I3 by 2, and this will equate to 0. So this is basically something which exactly is also equating to 0, right? Now, you see, if I solve this particular equation, this cancel out each other, and if you solve this, you'll get I1 equal to I2. Similarly, if you take any other loop, you'll get I1 equal to I2 equal to I3. So these three currents are equal, which we basically assumed in the beginning also, because every path is symmetric. So basically all the paths are equal. And if these are equal, this becomes I by 3 from here, from equation 1, right? Now, I need to find what is the equivalent resistance. So basically I need to find E by I. So I need to write I in terms of E now. So next loop which I will take should have this E also. So let's take this inside loop itself, the simple one. So if I take the loop, the loop name is A, F, G, D, H, and then A. So this is my loop, right? This is the loop, right? Now if I write KVL in this loop, let me put the signs here, right? So this becomes minus I3R minus I3 by 2R minus I2 plus I3 by 2 into R and plus E equal to 0, right? But you know that I1 equal to I2 equal to I3. So let me put I2 equal to I3 maybe, okay? So E becomes, if you solve all this, E will become 5 by 2 I3 into R, right? 5 by 2 I3 into R, if I'm able to calculate it properly. And if I see, so this is minus 1, minus 1, minus 2. So 5 by 2 into I3 into R, okay? Now, what is I3? I3 is what? I3 is nothing but I by 3. So if I put I3 equal to I by 3, this becomes 5IR by 6. And if I find E by I, this becomes 5R by 6. And E by I is nothing but R equivalent. So equivalent resistance between the body diagonal of a cube along all the sides where equivalent resistance R is placed is 5R by 6. So similarly, these questions look complex, but they are very easy to handle when you apply the right symmetry parameters and apply the right, choose the proper KVL loops, right? It's very easy to handle these type of problems. Okay, the next problem for us is, the circuit is given. We need to find the value of capital R resistor at which the potential difference at first cell becomes 0. So there are two cells given in this circuit. First cell has an EMF of 2E and internal resistance of R1. Another cell has resistance of R2 and EMF of E, and both are connected in series. And this combination is connected in series across a resistor of resistance R, and we need to find the value of R when the potential difference across this first cell becomes 0, means across this cell, right? So can I reframe this diagram and remove this R1 and R2 and place a resistor in place of R1 and R2, so that we have a clarity that we need to consider that as well. So this is a resistor here, this is a resistor here, this is R1 and this is R2, right? Okay. And let's say this point is A, this point is B, this point is C, right? And this is again AC, right? Now, potential difference across first cell, which is VAB, is 0, is what is given to us, right? Before understanding that, let's understand what is the current flowing through this circuit. What is the current flowing? Okay. So, for example, let's say I is the current flowing this circuit, right? So what is current? Current is, according to Ohm's law, current is voltage by resistance, right? So I becomes what? I becomes 2E plus E, because cells are in series, by R1 plus R2 plus R, which basically becomes 3E by R plus R1 plus R2, right? This is the current. Now, what happens is, the voltage across AB is given as 0. According to this question, the voltage across AB is 0, right? Which is basically the terminal voltage. So you know VAB is 0 is what is given to us. So what is VAB? VAB will be 2E, which is EMF, minus current times R1, which is equal to 0. Correct? 2E minus IR R1 equal to 0. You know V equal to E minus IR, right? So 2E is obviously given to us. We'll put the value of I here. So 2E equal to 3E by R plus R1 plus R2 into R1. So EE will cancel out each other, right? So this becomes 2R plus 2R1 plus 2R2 equal to 3R1, right? So this becomes 2R equal to R1 minus 2R2, and R becomes R1 by 2 minus R2. So if I choose a resistor of resistance R1 by 2 minus R2, then only I'll be able to make potential difference across first cell as 0. There is no other way, right? So let's move to the next one. So in this problem, this is the circuit which is given, and we need to find the value of current in 2 ohm resistor, right? So this is the 2 ohm resistor on the top. But you see, what are the components in this circuit? We have a capacitor also. This is something new to us. We have a capacitor of 2 microfarad. Then we have 3 resistors like that. Then we have a cell and one more resistor. So 4 resistor, 1 capacitor, 1 cell, and they are connected in this fashion. And we need to find what is the current here. For example, let's map this current as I. So what is I is what we need to find in this circuit, right? So I think first we need to think about the capacitor, right? We need to think about the capacitor. So we already have studied the transient response of a RC circuit, on how RC circuit responds, how the voltage starts developing, how initially it responds to the change, but finally it becomes like an insulator, right? So whenever a capacitor is given in these type of DC circuits, right? This is a DC circuit, the voltage is not fluctuating, it's a fixed voltage. So we assume that capacitor is at the saturated condition, basically means that capacitor is at the condition where it is not taking any more current and it has become saturated, and hence we can treat it as a open circuit, right? We can treat it as a open circuit. So if you remember in RC circuit, right, if I draw a sample RC circuit here, this is a sample RC circuit, this is capacitor, this is resistor. If I connect this across a V voltage, so if you remember, the voltage across capacitor is given by what? Let's say this is E. So it is given by 1 minus e to the power minus t by RC, right? This is how the voltage is given by. And the current is given by somewhere like this, E by R, e to the power minus t by RC, right? So if you see at time equal to 0, this circuit will have maximum current, right? At time equal to 0, this capacitor will have maximum current and it won't restrict anything, like it will behave exactly like a proper conductor. But at time equal to infinity, this circuit will behave like an insulator and the current becomes 0 and capacitor gets full voltage across it. Capacitor will get the full voltage across it, right? So generally we say that in DC circuits, whenever a condition like this and whenever nothing is mentioned, we assume that the capacitor is at this open circuit condition where it has got the maximum possible voltage across it and it won't allow any further current to pass. So this capacitor becomes a open circuit for us. And if it opens the circuit, this 4 ohm also has no role in this. So this also won't allow current to pass. So we just have a simple branch. Now you should be able to find what is the value of current in 2 ohm, right? So let's understand what is the current in 2 ohm. Before doing that, let's draw the equivalent for this, right? Equivalent will be, so 2 and 3 are in parallel, so they will be equivalent to this. And then we have 2.8, and then we have the voltage source, and this is connected like this. So what is the parallel equivalent of 2 ohm and 3 ohm? This becomes what? 6 by 5 ohm, basically 1.2 ohm, right? 2 parallel 3 is 1.2 ohm, correct? Now what is the net current? So if I find the net current, so net current through circuit is 6 by 2.8 plus 1.2, which is 1.5 ampere. This is the net current. So 1.5 ampere is coming here and it is getting distributed in this 2 ohm and 3 ohm, and we need to find what is the current in 2 ohm resistor. We need to find what is the current in 2 ohm resistor, right? So analytically, if you see, current is nothing but voltage by resistance, and 2 ohm and 3 ohm are connected in parallel, but the voltage is same, so current will distribute according to the resistance. So whatever has the highest resistance will get the lowest current, and whatever has the lowest resistance will get the max current. So they are inversely proportional here, right? They are inversely proportional. Okay, so let me say that this guy gets a current of maybe I, which is we have indicated, and this gets a current of I1. So can I write it like this, that 1.5 equal to I plus I1? This is my one equation, very simple equation. And other is, I said that they are inversely proportional to each other. So I into 2 will be equal to 3 into I1. I into 2 will be equal to 3 into I1. Now, if I find I becomes what? I1 becomes what? 2I by 3. So now we'll put the value of I1 in first and we'll be able to find what is I. So 1.5 equal to I plus 2I by 3, which basically becomes 5I by 3. So I becomes what? 0.9 ampere, right? So this gets 0.9 ampere and this will get 0.6 ampere, right? Because this has more resistance, it will get low current. 2 is lesser than 3, so it gets more current. So final answer is 0.9 ampere, 0.9 ampere, right? So let's move to the next one. Okay, let's move to the next one. So this is a circuit given to us. We have two cells, we have two resistors, and we are given that there are 2 points on this circuit, A and B, and potential difference between A and B is given as x by 9. So we need to find what is x. Okay, so let's forget this for now. Let's understand. Let's find what is potential difference across A and B. Then we'll find what is x and all that, right? So cells also have an internal resistance. So let's draw them here. 2.5 ohm and 2.5 ohm, right? Let's draw this. So this is the internal resistance of cell, 2.5 ohm and 2.5 ohm, right? Let's say this point is C, this point is D. Okay. Now we have indicated the nodes. Now, to find the potential difference between A and B, we need to find what is the current flowing across this circuit, right? What is the current flowing? So let's say the current I is flowing across this circuit, and we will apply the KVL and find what is I. So before doing that, let's place the signs. So battery, you know the signs already. I'll just place for the resistors the same way how we used to do in the KVL problems, right? Now let's apply the KVL and find what is I. Okay, starting from A, and I'll start from A and end at A. So this becomes plus 10 minus 2.5 I minus 2.5 I minus 5 minus 15 I minus 25 I equal to 0, right? So 5 equal to 45 I equal to 1 by 9. So 1 by 9 ampere is the current which is flowing across this circuit, right? And now we need to find what is the potential difference between A and B. So we'll start at A and go till B. So either we can come like this or we can come like this. Anyway, we will get the same potential, right? So let's start with a simple one. Maybe this is the simple one for us. So maybe we'll do the simple one. But anyway, you can choose any of the path that is not of any concern, right? So VA, right? VA plus 25I plus 15I, right? Plus 15I equal to VB. This is how we start. We start at 1, then we put the other potential, and lastly we, on the RHS, we put the destination point. So VAB is nothing but minus of 40 into I, which is minus 40 by 9. Minus 40 by 9. Now, this is given as x by 9 in the problem. x by 9. So x is nothing but minus 40. X is nothing but minus 40. Yeah. So this is the next problem for us. We need to find the potential difference across this capacitor after long time. After long time basically means after infinite time. So capacitor is behaving like an insulator, like we solved the previous one. So let's indicate the nodes A, B, C, D, E, F, G, right? So now if I talk about capacitor after a long time, it will behave like a open circuit or an insulator. So this path is kind of open circuit for us. This path is open circuit for us. So can I break this path like this? I'll say that this is open circuit. Now the current won't go even here. So this D and C becomes the same point because there is no current. So potential at C and D becomes same. So now I can either write C as D is C or as D or D as C, does not matter. So we need to find what? We need to find the potential difference across capacitor after a long time. So we need to find what is VBD or VBC, right? Because across capacitor we have B and C, and we need to find potential difference between B and C points. C, since it is D now, so B and D, right? So before doing that, let's understand this circuit a bit. This is a very simple circuit now because everything has gone up, and now we have just a network of series of parallel resistors, right? So let's say the current I is what is going through this battery, right? And then we have this kind of network, right? This kind of a network. So this network, you can easily say that this R and this R are in series, right? Which is in parallel with this R. So this is looking like this. So this R and R makes 2R, which is now connected in parallel with R, and this is again one R, and this is connected across a battery of voltage V equal to 15, and R is nothing but 3. So now what is the net current? I can easily calculate and say what will be the current. So I will be what? 2R and R are in parallel to each other. That makes 2R by 3 and plus R 5R by 3. So V upon 5R by 3. So 3V by 5R. So 3 by 5 into 15 by 3. Right? This is my current. 3 by 5 into 15 by 3. So this 3 go. So 3 ampere is the current which is entering this network. 3 ampere is the current which is entering that network, right? But we need to find the potential difference across B and D, right? Which we should not be able to find directly using this. So let's split those points. Let's split those points and understand, right? So if I split it, can I split it like this? So I'll place 2 resistors here, right? 2 resistors here, and B is here, and D is here, and this is my B and D. This current I know, which is basically this current, I and I, but I need the current here also, let's say I1, so that I can find the potential across this resistor, because this is also coming in the path between B and D, right? Let's say this R, and this is also R. So this R is also coming here into the picture. So again, this I is getting distributed between R and 2R, right? So now you can easily imagine and tell me, or you can also calculate and tell me, that if a current of 3 ampere goes in a parallel network of which one is 2R and other is R, in which ratio it will be distributed? In the ratio of 1:2. Because the resistor with a resistance 2R gets the less current, or half of the current, than the resistor which is having the resistance R, right? Or there can be the simple way to find this. Let's do that. Let's say this is I1, and the other one becomes what? Other one becomes I minus I1. And you know that they are inversely proportional to each other. So 2R into I1 equal to R into I minus I1. So 2I1 equal to I minus I1. I is 3. So 3I1 equal to 3. So I1 becomes 1 ampere. So this network is getting 1 ampere now. Now you can find what is VBD. So let's start from B and reach till D. So VB minus 1 into R means 1 into 3 minus 3 into 3 equal to VD. So VBD is nothing but 12 volts. VBD is nothing but 12 volts. It's a very simple problem. It's just that you need to understand the concept of the capacitor, because we are given here that it is after long time. So we have eliminated the capacitor from the circuit. So the final voltage across capacitor is 12 volts. So we'll solve more problems of current, electricity, and how current and magnetism are also related to each other. That we will see from the next chapter. Till then, thanks.